Hi everyone, welcome to today's class. Today we are going to discuss about what are the TCP options. We are going to look at what are the TCP options we have, and we'll see how the sequence number and acknowledgement number works in TCP. And then we'll look at what exactly the retransmissions and how we can filter the retransmissions. Followed by that, we'll look into what is FIN and resets. Fins and resets are the flags in TCP. So we'll go in detail about that. So to start with, let me go with the TCP options, and I'll give an overview about the TCP connection establishment. We discussed about the TCP connection establishment, um, you know, before last week. In the last class, we discussed about how this TCP SYNAC and ACK works. We didn't go deep about that. So today's class is more with what are the TCP options we have. So let me start with TCP options first. So if you look at this, so selective acknowledgement. Selective acknowledgement is something we got, we know this connection establishment. So let me open the paint to be much helpful to explain better. Okay. So let me make this sender and receiver. And we know the three-way handshake. So the first packet is SYN. This is SYNAC from the receiver. And finally ACK. So this is the sender and this is the receiver. And we say this is connection oriented protocol. And we got 4 tuple connection, right? The first thing is source IP, source port. And this is destination IP address and destination port. So 4 tuple connection, source IP, destination IP, source port, destination port. So 4 parameters involved here. And this is connection oriented. So we know about that. So once this has successfully happened, and once this connection establishment is successful, once a connection establishment is successful, only then the TCP will share about this TCP options. So imagine we got 10 gig link fat pipe that goes inside the ocean. And back in 1981, 1980s, where this TCP was emerging and TCP exists, we do not have an option like TCP options. That is pretty simple, I would say. So window size is a buffer. The amount of data what I can hold. Maximum data I can hold. So So that is 65,535 bytes. This is a maximum, but if I got a fat 10 gig link, as I said, if the sender is sending more data, is transmitting more data, so how do I going to receive that? So to overcome this challenge, they introduce the TCP options. And for this TCP option, if the TCP option should work, then both end has to synchronize with same TCP options. It has to be enabled and supported on both ends. So that is one parameter of the very important parameter of TCP option is selective acknowledgement. We'll go one by one. So I'm just listing out all the options we have. So this comes under TCP options. So why this is important? Because when you do a troubleshooting, you should know what is TCP selective acknowledgement. So only then you can figure out where exactly I'm losing this TCP stream. So now let me open the Wireshark and let me show you what is TCP selection acknowledgement. So if you look at this, this is my very first packet from the source to destination. And this is a client. So this is a client. And this is a server. So the very first packet here is a SYN packet. And for the SYN, I get a SYNAC. For the very first SYN packet, what are the TCP options I have? So to do that, you have to drill down this transmission control protocol TCP, and you can see the list of options here. So I support the maximum segment size is 1460 bytes. That's the maximum I can hold. And this window scale, you have to multiply the window scale by 4. So now what is my window size? It's 8192, and you have to multiply this value by 4. That is the maximum. So to put it across in a very simple perspective, let's say 1 gig is my maximum data I can receive. That's the advertisement it does during the SYN. When I'm sending a SYN to the destination, I'm saying my maximum segment size is 1460 bytes, and my window size is 8192 bytes, and you can multiply by 4, and the maximum is 1 gig is my maximum across the world. So this is a maximum amount of data I can hold. And the other thing we discussed about the very key parameters we use in the TCP options are maximum segment size, then SAC. So it should be always the SAC should be permitted on both ends. Only then this options will work. Why this TCP options? No, that's been evolved and enhanced just because to hold up more data, because now the network is growing fast and we have got 10 gig fat pipe under the ocean, and I cannot work with the normal TCP window, a minimum window size value. So they evolved and they created all this, the TCP options. And coming to SAC, what is selective acknowledgement? I'll tell you. See, example, if I got my communication happening like this, so SAC, as I told, it has to be enabled on both ends, only then it works. So if you go back here, even I see SAC is permitted on the destination. This is a destination here. And this is a source. So it's enabled on both ends, client and server. So this is a key thing you should look at when you look for the SAC, selective acknowledgement field parameters in TCP. So I got it. So it's a successful TCP handshake happened. Synac ACK. I'm successful, so I'm ready to send a data. So the protocol used here is HTTP. So if you drill down and if you actually see this, all this black coloring rules, this is all your bad TCP. There is something happened here. So it could be a network problem or it could be an application issue, but how do I find that? So here comes the selective acknowledgement. If you look at here, it says the selective acknowledgement says the sequence number 59861 to 61321. I'm missing some packets between 59861 and 61321. There's some packets that's missing in the middle between 59861 and 65321. And now here comes what is duplicate acknowledgement. So Wireshark is very intelligent to figure out that if you actually see, it says a packet number 53. Use a different color here. So packet number 53, exactly here. My TCP communication happened successfully here, but it says TCP previous segment not captured. So I am missing some packet. I'm missing a segment of packet. Example here, if you got multiple segments like this 1, 2, 3, 4, this is the range 59861 and 61321. So example, this is 59321. Sorry, 59861 between 61321. So I'm missing a packet between these two. And it says it's a duplicate acknowledgement because I acknowledge this back. So here I see all these acknowledgements here, right? And how I did that here, I have to go to TCP, and you should always look at the relative sequence number. So the three fields is very important. So sequence number, relative sequence number, relative acknowledgement number, and the next sequence number. So these are the three fields I have added here. I'll tell you why we need that. So how do I make this as a filter here? I'll show you that. So you have to click on it, right click, and we discussed in the previous classes, so you can apply as a column. I did that exactly. And since I'm adding more fields, I'm adding more information in the Wireshark, so it has to be very compactable from my screen layout. So what I did is you have to right click on it and you have to click on edit column and you can change the name. I change this name. So by default, it will give us an acknowledgement and you can change your value here. And if you click OK, that's going to save your filter here. So I did the same thing for everything. So I went to sequence number, relative sequence number, not raw sequence number. Always the Wireshark is interested in, we look at only the relative sequence number for troubleshooting. So I have to right click, apply as a column. Once it is applied, it will be applied as a column, and you have to click on the particular column and you should edit and you can change the value here. I just renamed. I didn't do anything else, only that. So it says this particular acknowledgement 46721. Right, it says packet number 53. If you see the acknowledgement number here, I have already acknowledged 46721. But I am doing this acknowledgement again, where the source is saying So I'm acknowledging it back again. If you actually see this 53#2, it's that I have already acknowledged 46721, but I'm again doing an acknowledgement because why? I am missing a packet after 46721. So this is how you can find, when you see black filters and the TCP bad TCP, you have to figure out. And here in the selective acknowledgement option, you come to know what exact stream I'm missing. So this is important to know for selective acknowledgement here. So this is how the selective acknowledgement works. So I missed this particular segment. So I'm not doing a retransmission for the whole process. Example, see, I send a SYN and I get a SYNAC back and I acknowledge, right? SYN, SYNAC, and ACK. The connection established successfully. Then coming back to the paint. So this connection establishment happened successfully and my TCP streams is going on between source and destination. So in this particular TCP streams, one particular segment, I'm losing a segment example. Let me number this as this is a sequence number 1456. Solve the sequence generated by the Wireshark, right? Sequence number 5678. So it's saying I'm missing the sequence number between 1456 and 5678. So instead of the whole process, what happens if there is no selective acknowledgement? It has to do a retransmission for the whole process from beginning. From beginning, it has to do the retransmission from top to bottom. So instead of that, I am missing out only one particular segment. So I want that to be retransmitted back. So Wireshark going to show you that. So previous segment not captured, and it is sending a duplicate acknowledgement again. So if you see here, again, the client is sending duplicate acknowledgement because I'm not receiving any data after this. After 4672, I'm not getting a data. But if you see here, again, the sequence number is 46721. And along with this data, if you add, you will get 4818. So it's retransmitting the data. So this is my payload 1460 plus the sequence number 46721, and you will get this value. So my next sequence number is 4818. So it is retransmitting back. If you look at this all duplicate acknowledgements sent from the client to the server. And now again, the server is sending back the retransmission. I'm retransmitting this data because you missed this data. So I'm doing a retransmission here. So this is how the retransmission works here. So now we should know, okay, what is fast retransmission and what is a duplicate acknowledgement, what is TCP out of order. So if you see a lot of these packets, then there is a problem with the network. But if it is minimal and if the retransmission happens and if you see the FIN packet, your communication is successful. To filter this communication is successful, we have a filter to find about FIN. And before that, I'll give you a glimpse about what exactly the FIN is. So if I see a lot of retransmissions, it's keep happening, right? That should be the, depends on the circumstances. There is a circumstances you see a lot of retransmission, then there is a problem with the packet loss, network issues, it's not responding. So we have a lab, so we'll see how this retransmission happens and how this FIN works. But I'm giving an overview about what is retransmission. So this is something see if you see this particular server keeps sending a data here. And there is a point where exactly you can see, hey, my window is full. The server says my window is full. You don't send any data, wait for some time. So after some time, again, the server is retransmitting because you requested for some segments and I was busy. My TCP window is full. I'm full. My window size, see, if you see this, this is the window size and my window is full. I cannot hold up any more data beyond this. So that's the meaning of TCP window full. So my window is full. You cannot send any more data. You have to wait. And after that, it is again retransmitting. So when there is a problem happens with slowness or irrespective of an applications or whatever it is, but you have to check this. Who is doing the retransmission? Is it the client or server? So that is a key thing to understand where the problem is. Now the server window is full. It is processing some other client's data and it is full and it's asking the client, hey, wait for some time. I will retransmit your data. So if the retransmission happens and if you see the fin packet, then yes, my communication is successfully happened and I finished my exchange. So there comes the fin and reset. I'll tell you the key difference between fin and reset. So here the communication is keep happening. I send the data, I receive an acknowledgement, I keep sending other sequence of data and getting an acknowledgement back. So what if my connection is completely successful? If my connection is successful between source and destination, let me put this across. So my connection is successful here. I received all the data. So at this point, okay, I received all the data. The source is saying, okay, this is source and this is a destination. And destination, this is source. Connection successful. I received all the data. So finally, both end will say gracefully, let's close the connection is called fin. Let's finish this conversation. I received all the data, whatever you sent, I received it. So let's close this connection. That is fin flag. Reset. Example, if I try to establish a connection on port with the port number 2356, a random port, and the destination is something, a random port 4567, and I'm blocking this port. So what happens? I'm not ready to listen on port 4567. I'm not going to respond on this. So what happens here? So here happens the reset. Who is going to reset? The destination is going to reset this. I'm going to reset your connection. I cannot accept your connection on port 4567 because that is blocked. And you're doing some malicious thing. You're doing scanning. You're trying to intrude my connection. So I'm not interested to respond back. So that is abruptly, if you disconnect, it is a reset. And fin is both are gracefully closing the connection. Hey, I am good, you're good, so we are closing the connection. That's a graceful shutdown or gracefully closing the connection. So this is all about reset, fin, selective acknowledgement. So what we discussed here. So we discussed about 4 tuple connection. We discussed about what is SYN ACK and what are the TCP options and what are the parameters inside the TCP option. The main option is maximum segment size and the selective acknowledgement option. So what is the amount of data I receive, where I miss. And we discussed about what is duplicate acknowledgement and what is previous segment not captured, what is meaning of it, where the problem is. So how Wireshark is interpreting all these values, we looked at that. So now going forward, so this is all about this TCP selective acknowledgement and the options available with TCP retransmission and previous segment not found. So now let's move forward with the next topic. So how sequence and acknowledgement number works. So let me open up the Wireshark for it. And you have to make a filter exactly like this. These three filters are very important. TCP segment length. You can see here TCP segment length and sequence number, next sequence number, and acknowledgement number. So you have to keep your next sequence number next to sequence number. That's how you can, compare. So now let's discuss about how this sequence number and acknowledgement number works. So here, this is the very first packet, SYN packet. So I send a SYN and my next sequence number is 1. So from here, I didn't send any data. I didn't send any payload. This is just an connection establishment and my TTL is 0. So nothing is happening here at this point. And the acknowledgement, this is called a ghost bit by Wireshark. This is happening, but no real acknowledgement is happening at this point. So for this SYN, it is sending a SYNAC back. If you look at the sequence number 0, and the next sequence number is 0, and acknowledgement is 1. This is just to say I accepted your SYN and I'm okay with your SYN. I am going to send you SYNAC back. And exactly here, no data is exchanged. Only these fields are called ghost bits. So you don't want to consider until this point. So you have to check only SYN SYNAC ACK. It's successful. And you can compare the fields inside the TCP flags. Acknowledgement bit set. And if you look at this SYN-ACK, both SYN and acknowledgement bit set. This is all ghost bits. No actual data communication is happening here. So when you look at here, exactly here in HTTP, we send a data of 324 bytes of data. We send this. And what is my next sequence number? 325. So what it says, I got 325 and then I acknowledge 325. It's that, okay, you send a data of 324 plus the next sequence number 1, that is 325. That's how it works. Your TCP segment length with sequence number 1, it becomes 325 and I acknowledge 325. It means that, okay, I got this data and I'm sending an acknowledgement back. And if you actually see this, this is a sequence number of 1460. And the next sequence number is 1461. So if you see here, the next sequence number is 1461. So this is how the sequence number and acknowledgement number works. So sequence number is nothing but it's a combination of values. Example here, see if I got a value, this is the payload 324 plus 1, and I get an acknowledgement for 325. It means that I add 1 to my actual payload, that becomes my sequence number, and I get an acknowledgement back. So this is how the sequence number and acknowledgement number works, and you should look at what exactly is missing. So because if you see this, if you see the bad TCP packets, you will understand better. So let's take this example. So it says previous segment not captured, and it is acknowledging for 325. Where is 325 here? Already packet number 53, the Wireshark is going to give you this option. So all my TCP streams has been successfully sent between source and destination. This little tick mark here, it says on packet 52, I offloaded all this traffic, whatever the receiver wants. Here the connection is successful. So here says it's a duplicate acknowledgement. Why? Because the previous segment not captured. So it acknowledges for 325, but it is missing out some data. And here exactly the retransmission happens here. If you see this, this is the next sequence number 46721. So it is retransmitted here. You can correlate this values here. So the next sequence number, it is missing here. And if you actually see, that's been sent from the server to source here exactly. So this is how, if you understand the sequence numbers, how it works, you can figure out where exactly retransmission happens, which set of data I am missing out exactly. And you can compare the values here. If I go to TCP duplicate acknowledgement, if it says 59861 to 61321, I'm missing some packets. The missing packets, it is retransmitting it back. So this is how the sequence number and acknowledgement number works. You have to do your own capture. If you keep practicing, you'll understand exactly how to compare and where to find the issues. So this is all about how sequence number and acknowledgement works. We know about that. Now we'll look at closer look at retransmission. We saw okay, I'll show you what is fin and resets. I have a capture for it. Let me open fin and reset capture. Let me close this. So let me open up this capture. So this is very simple filter you can apply to only to figure out the resets in TCP. TCP.flags.reset equal 1. So here it says out of 32 packets, the displayed value is 0. So I don't see any reset in this capture. So here exactly I see resets. That is abruptly disconnecting. So not a gracefully closing this connection. So to follow the stream, let me go to conversation filter, TCP. So no much data is exchanged. If you see, no much data is exchanged. So this is a source and destination, and vice versa. I send a SYN, and this destination is not interested, and you want to talk to me on port 80, and I don't want to respond you back. So it's abruptly disconnecting. That is reset. No much conversation happened here between source and destination. If you see how I'm saying this, because if you see this value TCP segment and 0, no much data is exchanged. It is just sending a SYN. It's sending no reset. I'm not interested to respond back on this my port 80, and I don't want to establish a connection there. So I'm going to reset this connection. So if my TCP connection is not established, so I cannot send any data, all my connections are dropped. The first thumb rule is you have to establish a successful connection. Only then your actual data transfer happens from this point. So this is about TCP reset. We'll do a lab for TCP fin retransmissions. So let's take a closer look on what is TCP